Okay, let's get started. Thanks so much for coming to watch my presentation. I'm going to be talking about a thing called the Beeline library. This is a little cool thing I've been working on. But another thing I want to do with this presentation is just give a general overview of like my current mindset in terms of like software development and where we're going. I'm really excited for the stuff that's coming up this year, just personally for like what I want to build and just for what's coming up in the iOS ecosystem in general. And yeah, I really hope you enjoy this presentation. And without further ado, let's get started. So, first of all, who am I? I'm Tim. Some people call me Tom, especially at this conference. Nice to meet you. I do iOS, I do video games, and I do karaoke. And that's pretty much it. Yeah, nice to meet you all. And I hope if you do any of these things too, I hope we can have a chat later on. I'm coming up on 5 years living in Japan now. It's been an absolutely crazy journey, and that's an absolute crazy milestone. And in my 5 years in Japan, I've had the privilege and the opportunity to work on a wide host of some very, very prolific apps, which I'm very grateful for. The first one, I worked at Macari for a couple of years here in Japan. I worked on the older version of the app, the one that looked like this, the 2013 edition one, not the rewrite that Macari is currently publishing right now. And this one, back in the day, was a mix of Objective-C and Swift and was mainly UI. Actually, no, it was completely UIKit. After Macari, I actually went and helped a buddy out on a game he's developing in a smaller development studio here in Japan called OS. And so I helped out with iPad OS integration for OS. OS is a multi-platform game engine. So as you can imagine, I went from Objective-C and Swift to C#, and the whole UI stack in OS is custom. So the lowest level system framework we were working with is OpenGL, which is it really humbles and puts in perspective just how much we get for free with UIKit, and just and really just drives home like how much we take for granted sometimes. But also is a really fun thing to work on. And they assure me now that they're actually working on a really cool concept of a abstract graphics API layer, so they can get rid of OpenGL and move to something more modern like Vulkan on Windows and Metal on Mac, which is really exciting. After OS, I actually worked at Honda, or a subsidiary of Honda called Drive Mode, and I worked on an app for Honda called Honda RoadSync. And RoadSync was basically a really small utility app that when people bought a Honda motorcycle, they could pair their phone to their Honda motorcycle, which is the biggest accessory possible, I would imagine. And then you can actually, while you're driving a motorcycle, you can operate your phone, things like play music and the likes, through a Bluetooth interface on the Honda motorcycle. And that was some really cool tech. And it was extremely cutting edge. I went from C# and OpenGL to Swift and Swift UI. We built the whole app in Swift UI, which was a really cool experience to see like exactly what the absolute cutting edge of iOS development is then. And then finally, about a year ago, I joined none other than Instagram. And we have a small little engineering team here in Tokyo, a very passionate group of developers who are just an absolute blast to hang out with. And we're doing some really fun stuff with the app. And I really hope that we can share some more stuff with you soon. But as I'm sure you're aware of, Instagram is Objective-C and UIKit. So I did like, if you look at this list of technologies here, I feel like I did one whole rotation of the iOS developer experience. It's absolutely crazy. But yeah, and so I'm really looking forward to like just what comes next as a result of this. So when I'm not working, not writing iOS at work, I write iOS at home. And one app that I write a lot is that I really like is an app called iComics. And as you can see, iComics has been around for a while. It had a very skeuomorphic design back in the day. And the idea for this app was it's a DRM-free comic book reader. So the idea is there's a lot of websites out there who sell comic books in an open format that anyone can read, but you need an app in order to read it. That's like a comic book zip file format and things like that. And so the idea is this is just a like a publisher agnostic reader for comic book apps. The idea is you provide the content, but my app will provide the reading experience. And so the idea is to try and make this the most nice reading experience on iOS devices as possible. But that being said, as you can see, iComics is from a different time. The iPad 1 had a single core CPU, it had 256 megs of RAM, and a lot of the stuff that we take for granted now, including things like UI collection view, didn't exist. So this year, I want to start work on what I'm calling iComics 2. And here's a quick mock-up of stuff I'm looking at right now. As you can see, I'm trying to make it a lot more simplified than iComics 1. And there's a lot of engineering challenges that I want to undertake with this app. First of all, I'm going to rewrite the whole main module in Swift. So I still love Objective-C, which is good, working at Instagram. But the main thing is we're definitely at a point where we're like at a midpoint now where it just the advantages of Swift and the disadvantages of Objective-C just in this modern era, this modern age right now, is just gotten so disproportionate at this point that it just makes complete sense to just rewrite the whole thing in Swift. Swift lets you move a lot quicker, it lets you write more flexible code, and it lets you achieve the same thing with like way less code than what the same thing in Objective-C would be. So at this point, it's definitely like it's a no-brainer that this thing will be like mainly Swift, but dependencies can be Objective-C, but they'll be like fully modularized away, so they look like they're Swift interfaces to the main core of the app. Another thing that's been really crazy over the last few years is comic book page data has gotten massive, absolutely massive, to the point where UI image view to try and handle displaying these pages in the best way possible has kind of like just hit its limitation. Like UI image view was not designed for massive images, and certainly not all sorts of cool things like pixel resampling and the likes. And so something I've been researching for the last year is how to write a metal renderer, which I can then get pixel per pixel level control of rendering the page image data, which is hopefully worth a talk down the line, assuming it works. But that's something I'm looking into right now. Something I also want to do, this is like just an intellectual curiosity. I think it's very obvious in the latest iOS versions that we're heading towards some kind of new design paradigm where Apple's preferring rounded rectangles than having little separated lines, like in like UI table view. So I'm curious, could I design a full screen app on iPadOS and not use separated lines? Just use white space and rounded rectangles, and then negative space just defines the boundaries. Now, maybe this is impossible, but maybe it would work and it would look really cool. And another thing, I really love CocoaPods. CocoaPods has been a fantastic dependency manager, but the allure of SPM is kind of insane at this point, because what this means is if you can move your app to SPM, you don't need a Ruby environment to manage a complex dependency graph for a very complex app. You can just download the repo, open it up, and start going. So the idea here would be like, could I actually make it that the app would be extremely easy to set up on a new Mac straight away and work on if I replaced CocoaPods with SPM? Another cool thing about SPM is because you can have like internal, similar to CocoaPods, you can have internal copies, internal modules in your own like app binary. So you could do this really cool thing where it's like a framework, but you're just modularizing the code around SPM. So SPM it's kind of like CocoaPods, but in the same app. And the idea I'm thinking here is that with this in mind, it'd be really easy to have like separate bits of the app I could work on without having to recompile the rest of the app. And especially with things like sandbox apps, this would mean you could really iterate quickly on things and not have to worry about like building the whole thing every single time. And of course, iComics 1 was designed in such a foundational way that it won't work on Mac without rewriting the whole thing, which is a good thing that I'm doing this. But I definitely want to look at macOS support via Mac Catalyst as like a first-class citizen of iComics 2. And one final stretch goal, a Windows version. Now, this one, if anyone wants to talk about this, I got some ideas. I'd love to see what your opinion is too. But a Windows version would be pretty cool. And anyway, so having worked at a bunch of companies at this point, I'm trying to think about how I want to actually manage like state in this app. Like, how do I actually want to architect this app, basically? The thing is, when you think about an app, what an app is some kind of in-memory state that is driving a UI. And then whenever that state changes, something has to tell the UI to update. And this is like a very fundamental sort of like requirement of software development. And I feel like over the past few years, I've definitely seen two sides of a spectrum. Basically, you've got incredibly manual state management, and that's things like delegates. So, for example, if a view controller changes an object, it'll fire a delegate telling something else that it changed the data, and so it should also respond. So every time you need something to update to a data mutation, you manually implement a method that calls it. And the good thing about this one is it's super easy to learn. This is like 2008 level iOS development. So it's super easy to learn. And because they're just methods, it's super easy to debug. You can set a breakpoint if it's not firing and see what happens. But the downside is a lot of boilerplate code. And certainly doing this manually, the more complicated your app becomes, if you don't have some sort of level of like automation, what will start happening here is you will start missing things. Bugs will start happening, and there'll be a lot of, because you've missed something in your piping code, and that becomes an issue. On the other side, you've got like the kind of the opposite, where state just exists in memory, and then everything subscribes to the state, and then the UI updates sort of like as a side effect. And this is using like reactive frameworks like Combine and RX Swift. And so there's a really good appeal to that, because as you can see, it's far less code, and it means that you can basically catch all the edge cases, because you sort of just subscribe wherever you want, and you don't have to keep making all this piping code. But the problem is, it's such a different mindset to manual development that it is hard to learn. It is also hard to convince teams to adopt it. And the one that really has me a bit worried, although I think it's gotten a lot better in recent times, is it's very hard to debug. Like if everything is a functional statement, where do you set the breakpoint? So what I want to do with iComics 2 is I want to go right down the middle. I want to have like nothing like not super magic, but also not super manual. Somewhere where I can like get some nice automatic wins, but at the same time keep it very easy and very debuggable. And so that is the mindset I'm going into about Beeline, this little library I've made here. But before we go on, I just want to say something really, really quickly, just because I think this needs saying. Just remember here, everyone, software development is hard. That's why that's why the salaries are usually pretty good. And there is no 100% correct way to write a solution to a given engineering problem. I would say that the best solution is whatever produces software that delights the users. If the users really love it, then that's definitely the best solution. The problem is that time is the biggest counter to this. So if you can move quickly, you can create more and more features for users. But at the same time, if you don't create a good experience in the process, like if it becomes buggy or if it's slow or it just crashes and things like that, you have a lot of our time is trying to make the best software that we can with the time that we have. So just to go ahead, like Beeline's concept might be good, it might be bad. This is your opinion, and it might be my opinion. I think it's really cool, and I really want to use it. But the idea is, hopefully I'm going to present you some new software here, and you'll find it really interesting. So without further ado, let's go. So hopefully you've seen this before. Hopefully, if you're an iOS developer, you've probably seen this before. Whenever you want to move from one view controller to another in an iOS app, usually what happens is some function will be called. Inside that function, a view controller will be instantiated, and then that view controller will be pushed onto the navigation controller stack of the same view controller here. Now, this is fine. This is completely fine, okay? Until it's not fine. So I just want to say, like, sometimes when you talk about development and people are like, no, don't do that. Don't never, ever do that. Like, the thing to remember is everything has a time and a place. So doing an inline view controller is fine, depending if you don't need any of this complexity or if it's a really small thing. So this isn't like a hard set rule. Like, always, never just assume everything is a rule. Just go, yeah, just use your best judgment, just realize what the implications might be down the line. So speaking of down the line, the first issue here is redundancy. Like, if you have maybe separate view controllers that all push to the same view controller, that means each one has to be in charge of instantiating this view controller. So right there, if you want to change the name of the view controller, you have all these points here. So redundancy is not great. The next one, this becomes a bit more visible down the line when you start working with really big view controllers. They might have a lot of dependencies or objects they rely on in order to be instantiated. And so the problem here is you've now tightly coupled this view controller to the current view controller. And basically, the current view controller has to know this view controller's entire life story in order to create it, which shouldn't really be this current view controller's job. So it's right here. This is like a really big thing that makes it a bit more. This is a really big kind of like issue that starts showing, like, if it's really small view controller is fine, but once it starts getting bigger, this starts to break apart. And another thing is, like, if you want to start doing deep linking in your app. So for example, iComics 1 has a widget where you can tap your last read comic and it will open it up in the app. The problem here is, like, there is a lot of complex state management to do this, because you basically open the app at any specific UI state, and then something has to be aware of like what the current state is and how to tear it down, how to set up the new one. And then if there's any animations, how to collect all the necessary data, maybe like a thumbnail from one view controller, moving to a thumbnail in another view controller, and playing that animation. So like that's a whole lot of work. And whose responsibility is that? And just to show at home, this is a transition animation I was just working on. But yeah, these are two separate view controllers. This is a transition between two separate view controllers. And so these things should be like you can see that because of this animation, they look very tightly coupled. But the idea should be here that these two view controllers can exist without them. So the issue becomes like these two view controllers shouldn't know each other exist. So when presenting it, like something has to be aware of how to word this. They should be decoupled. Like there should be no like there should be like an abstract controller for the animation. But at the moment, the library view controller explicitly knows the comic view controller is there, and this is like a paradigm that shouldn't happen. Like there should be some other object in the middle that sort of like controls the link between both of them. And so, like I said, this shouldn't be view controller's responsibility. View controllers should be self-contained, and like they only care about themselves, and they shouldn't be worrying about any other view controller that isn't like a child of them. And so usually what this means is at the top of a root view controller stack in an app, some object, hint hint, should be in charge of managing all of your navigation state at any point. So so at the drop of any hat, something is aware of what the app is looking like right now, and is capable of just moving everything around to configure to the new state. And so the concept of a router isn't a new thing. Like it's been very like in the most popular. In one of the most popular iOS architectures, Viper, it's a first-class citizen in the name. The R in Viper stands for router. Let me see if I can guess the other ones too. V is view, I is interactor, P is presenter, and E is entity. And so as you can see, this just when you decompose an app into like a bunch of different responsibilities, router is right there at the top. It says first-class citizen. So the idea of a router is it's just an object, simple NS object, no, not even an object in Swift, that serves as the source of truth for the navigation state in the app. This is the thing that decides what is on the screen at any point. And so normally a router looks like this. You usually instantiate it, you give it the root view controller so it knows where the top of the chain is, and then you tell the router, or the router, I want to show a detail view controller. And usually it's like that. And so you just pass this object around for any view controller that wants to do this. But the problem is, how do you pass it around? Which is a problem. A cool thing I saw one of my good iOS buddies, Vincent Prade, do is he said you can actually use singletons as a default parameter for classes, which is really cool because then this means it's basically invisible from the outside when you instantiate this, that you're linking a global shared singleton router. But the problem is this is still a fair bit of code. Like this still means that every single time that you want to like have a router in a view controller, it has to be an instantiation argument, which again creates more complexity and starts doing more tight coupling, and you have to host it somewhere. And so this is still a lot of boilerplate code, which I want to try and avoid. It's like yeah, you could do it that way, and it's fine. It's fine. But surely there's a better way. And sure enough, I was like, oh, hang on a minute. I think I have an idea. Just at a random moment, I realized this really cool mechanism existed in UI view controller. And this is called show. And so this is different from things like push view controller. This is on the UI view controller level itself. It's a very abstract sort of method that basically what happens is any view controller can make a new view controller and then say, I want this view controller to be showed. And the cool thing is this is like already like decoupled from any other view controller, because then what happens is it goes up the chain until it basically goes up the chain of view controllers saying, hey, can you show view controllers? No. Okay, what about your parent? Can you? No. And then you'll get to some kind of display view controller, either a split view controller or a navigation controller that says, yes, I can. Let me take that off your hands and show it. And so this is cool because it's like you just broadcast your intent, and then something else will respond. But it might not respond. Like if the view controller isn't in a chain, nothing will happen, and that should be fine, right? It should just fall through as a no-op. I was like, ooh, hang on. So all we really have to do here is just take the same concept as the show a function from UI view controller, but just make it semantic. Instead of directly referencing a view controller, I just have to say, I just want to show a detailed view controller. And then the router can do that for me. And so the idea basically was, instead of directly referencing a view controller, you can abstract it with some kind of intent, in this case, just an enum. And a really cool thing here is, so now we're getting into like, why is Swift an awesome language? You can have associated values of enums. So you could say like, I want to show a view controller, and here are the parameters I need to show it that relate directly from the view controller that's calling it. Here's the context. And then with a little extension on UI view controller, I can just say show a route. Semantically show me this view controller. And then that's all that this view controller has to do. That's the whole thing. And then the same as before. Basically, you go down. It basically goes up the chain saying, do you have a router who can handle this? Do you? And it goes up to the top. And then the top will have a router. And then, yes, it will return yes that it was able to handle this and perform the transition. But the problem is, how do top view controllers have a router? So where is this router living right now? You got a very good answer for this. At this kind of conference, you might not like this answer, though. That is my boy, Objective-C. So this is a cool feature of Objective-C that I'm kind of sad that doesn't exist in Swift. I'm sure there's a way to do this in Swift. If there is, please come and tell me. You can use a feature called associated objects, which means that you can then store objects. You can create new properties on existing classes and then store objects here. So all I had to do is make a router property for UI view controller. And so now any view controller can have a router. And as you can see here at the bottom, all you need to do then is set the top level view controller to have a router. Or in this case, I'll talk about a little bit. You have to, I'll tell you what a little bit. You do have to have a subclass though. So I'll show you an example of right now. The idea is when you create your root view controller at creation time, you just have this extra line of code that says, I want this one to have the app level router. And the cool thing here is that since you can reference this router from the delegate, you can also use this to respond to deep link requests as well. And then the idea here is router is an abstract class that has a function called show. And the idea is this will automatically get called from that semantic request that goes up the chain, and you get the route that was called and then the source view controller that made that call. So you have enough context here to say like, okay, first of all, as a subclass of root, can I actually support it? So you can actually map it to the specific enum that you want to support, and then fail through if you don't. And then all you have to do, as you can see, is extract the data from the enum. And then in this case, knowing the source view controller and knowing that the source view controller would have a navigation controller, we can then just do the same logic as before that was in that child view controller, but now we're doing it in the router in a more centralized spot that has much more context about the state of the app. And here's what it looks like. So straight away, not a lot of code, but that was literally just, I want to show a view controller with an incrementing value of 1. And so this was going from the child view controller all the way up to the top of the chain. And then that's where the view controller is being instantiated. And that's it. Pretty easy, right? How cool is that? I mean, it's not a giant complicated concept, but it's the kind of thing that like when you think about it, it just makes it a bit simpler to work with. Like it just makes much more sense that everything's in a singular area. But what else can we do? So a cool side effect of this is you could have nested routers. Like something that I always think is a bit tricky with these kinds of things is you might have one object with a massive list. Like if you have one router with a ton of different route destinations, that would be kind of unwieldy. And so here you could actually start, if you have specific sections of your app with their own little self-contained navigation states, you can have separate routers. And all you have to do is just have a settings router for the top level settings view controller, and then you still have the app router at the very top. And so when you go up the chain, whenever a settings view controller semantically calls a settings route, the settings nav controller is the one that catches it and then performs that logic. And so this is really cool because now I can actually chunk up my logic into separate areas. So it's not just one unwieldy giant class. And then one last question. What about Swift UI? I feel like I just got to answer this question really quickly because this seems to be a very big point of contention in the iOS community, I think, at the moment. But we really shouldn't think of it like UIKit versus Swift UI. What you should really be thinking about is UIKit and Swift UI. Just remember, these are both tools for achieving software that will delight the users. And if you can use both effectively, you can use UIKit for precision, but you can also use Swift UI for extreme development speed and catching a lot of edge cases that you don't even catch in UIKit sometimes, things like big text and the likes. You get all of that for free. Certainly, I think that the best of both worlds is using both of them. I can't take credit for this. There was a really good talk at iOS Conf SG last week for Adam Bell. Fantastic, absolutely fantastic iOS engineer, and probably one of the main people who pioneer like motion design on iOS. Talked about this as well, and he showed a fantastic presentation on how you can have like very granular gesture control on a view via UIKit, but the view itself was a hosted Swift UI view. And so I definitely think that if you want to, at this point in time, Swift UI will very, very likely probably become the dominant one, but at the moment, I feel like if you really want to make an app right now and have like a really good experience and also move really quickly, you can use both, which is we're a really good state to be in right now. And so going back to iComics too, like if I was going to do that here, just like I said before, the middle bit would be like UIKit and Metal and a renderer, but all the auxiliary UI, all the stuff that's really finicky and like picky and like lots of math if you're going to do it like with auto layout or like UIKit, that could all just be Swift UI. And so right here, we've just got this fantastic hybrid of components that would that work together and create a really good experience with a lot less code than UIKit on its own would have required. So this works, but as you can see, this was really designed for UIKit. So it has to be a UI or NS hosting controller. And you can inject the router object itself as a Swift UI environment object. But the problem is you do lose that source view controller context. So that might be fine. If you can implement your router logic to handle that, that's fine. Or, but if you could get access to the hosting view controller itself, that would be the best thing. And I did look around, and it's doable. Like someone here actually made a really cool answer in Stack Overflow showing could you subclass NS hosting controller, and then in the subclass you actually expose itself as an accessible property on the Swift UI level. Certainly, I think that if you're going to do this for a giant app, it would make sense to have like specific subclasses of UI hosting controller, so you can have that level of control and you can reuse it as much as you want inside your own app. And that's basically the app. That's basically the library. So hopefully this is something that kind of gave you a new perspective. Well, yeah, and I'll go a little bit later. Hope this gives some perspective, but definitely please give the library a look. It's very small. I think sometimes people say that making things small and simple is harder than making stuff hard. But please take a look at the code and let me know what you think. And one last thing: why is it called Beeline? Well, I figured the problem with naming stuff in Swift is that if you're going to add it to CocoaPods, all the good names are taken right now because Swift libraries don't have prefix letter extensions. A lot of the time, these names are taken. Like router was already taken. And so I'm starting to come up with a lot more like abstract metaphors for my library names as a result. And I thought Beeline made complete sense. It's like moving from one point to another really quickly. And that just summed up the entire point of this library to begin with. And that's it. So the cool thing to take away here is Beeline is using existing Apple API concepts, but to remove boilerplate and to sort of like make things a bit more decoupled, but it's still a very familiar concept. And I really hope that just that example alone is something that people can think about here when they're moving forward, designing their next level of APIs, that this is the kind of stuff that you could use. It's very little code in the end, but as you can see, it just completely decouples the app. It handles all of my edge cases like deep linking. And so certainly I think these kinds of libraries, which are really small but powerful, are the kind of ones that really make good software. Something I thought about at the end of this was once I finished building it, I was like, wait a minute, why does it just have to be routing? Like you could put anything you want in the top view controller. So for things that for things like global app state, or things like networking or database access, like maybe this could be a really cheap and nasty dependency injection mechanism. Certainly, if that sounds interesting to you, I definitely encourage you to give it a shot and see. And if you do, please let us know. And something that I try and keep myself true to is that what we're trying to do here is when we're trying to build good software, we're trying to make these things really small objects that are completely decoupled, very modular, and above all, testable. And I really hope that this gave you some new perspectives. The goal here was to show my mindset at the moment of software development, and hopefully that gave you some new ideas, maybe some inspiration. I don't know about that. But the idea is hopefully this managed to challenge your way of thinking a bit and give you some new ideas on how to undo software development. And on that note, please go forth, make something awesome. And if you do, please make sure to show us at the next meetup. Thank you so much for watching. I hope you had a good time watching this presentation. And I'll see you later.